Good morning, students. In the last class, we discussed about the isomerism in organic compounds. In that, we discussed the structural isomers and its types. Okay. So, what are isomers means? Once again, I will recall that. What are isomers means? The compounds having same molecular formula but differ in their physical and chemical properties. So, those physical and chemical properties are differ by certain reasons. Okay, so that's why it is further classified into two types. One is structural isomer, another one is stereoisomer. Structural isomers mean the compounds having same molecular formula but differ in their structure. That is called structural isomerism. Means the differ in physical and chemical properties is due to different structures of the compounds. Okay, so another one is in that the four types are there. One is chain isomerism. Okay, next position isomerism, functional isomerism, metabolism. Chain isomerism means the different number of carbon atom in a parent chain. They are having same molecular formula but differ in having number of carbon atoms in the parent chain. And already I gave the example. Okay, so next one is which one? Position isomerism. So in that position isomerism, there is a difference in the position of the functional group in the both the compounds. I gave you example one butene and two butene. So that means at first position in one compound double bond is there, at second position double bond is there. But they are having same molecular formula. Okay. So the next one, functional isomerism means the compounds having same molecular formula but the functional groups are different. Only two pair of functional groups are there. One is for alcohol ethers, for ether alcohols, and for aldehyde ketones. For ketone aldehydes are the functional group. Only four pairs are known as a functional isomers: ketone aldehyde, aldehyde ketone, ether alcohol, alcohol ether. Okay, and the last one is mesomerism. So this is also explained in ethers and ketones. So on either side of the functional group, if the number of carbon atom and the parent chain is differ, then they are said to be mesomers. Okay, so now we will discuss with another isomers, that is stereomers. Stereo isomers. So students, as I told you, stereo means a particular position, a center. Stereo center means a particularly that position. What are stereoisomers means? Here they are having the compounds having isomers and isomerism. The compounds having same molecular formula and structural formula but differ in arrangement of atoms. Differ in arrangement of atoms in three-dimensional space. This is called stereoisomers. So in that two types is there. First one, geometrical isomerism. So students, this one in three-dimensional space called as stereoisomers. And continue next. And the phenomenon is called as stereoisomerism. Understand? So here, geometrical isomerism. Alright? So the compounds having same molecular formula and same structural formula but differ in their geometry. Understand? But it is the compounds having same, I'll write here, molecular formula and structural formula but differ in, you don't write SF and NF. Okay, complete the sentence like molecular formula and structural formula. Don't write MF and SF here. There is abundance in, sorry, lack of space is there, so just write like this. So the compounds having same molecular formula and structural formula but differ in their geometry. Differ in their geometry are called as geometrical isomers, and the phenomenon is called as geometrical isomerism. In this, again two types is there. One is cis isomers. Okay, there is no cis isomerism, simply a cis isomers. Means if identical atoms are adjacent to each other, then they are said to be cis isomers. But if identical atoms are adjacent to each other, then it is said to be cis isomer. Listen and take the example here. So listen, platinum NH3 twice Cl2. Okay, so students, here two types of atoms are there which are bonded to platinum. This is the central metal atom. This is NH3 twice Cl2. Are you getting? So this is one type of identical atom. This is another type of identical atom. So listen here. If I write the structure, platinum structure is like this, square planar. Listen, which are the identical species here? This NH3 and NH3. Here it is Cl and Cl. So with respect to this is the adjacent place. With respect to this is the adjacent one. With respect to this is the adjacent one. So we'll compare these two. These two are identical species, which are adjacent, exactly next to them. So if two identical species are adjacent to each other, then they are said to be cis isomers. Okay, I'll take here only. So what are trans isomers? Trans isomers. Note our students, here it is adjacent means opposite. If identical atoms are opposite to each other, then they are said to be trans isomers. So listen and take same example because we want molecular formula same, that is platinum NH3 twice Cl2. So here if we consider the structure, students, this is also a square planar structure because listen, the compounds having same molecular formula, same structural formula. Your molecular formula is same, structure is also same, square planar. But differ in what? Arrangement of atoms. Okay? So here NH3 is here, NH3 is here, Cl is here, Cl is here. They are opposite to each other. Correct? So this type of isomerism is called geometrical isomerism, where the structure is same, molecular formula is same, only the arrangement of atoms are different. Understand? So this is about what is it? Geometrical isomers, either cis isomer and trans isomer. Cis isomer means the identical atoms are adjacent to each other. Trans isomers means the identical atoms are opposite to each other. So if we take another example, okay, let's just drop this. CO NH3 4 times Cl2 plus. Okay, next. Here also same. CO NH3 NH3, 4 times Cl2 plus. So listen students here, central metal atom is CO. Okay, so it is in octahedral shape. Then this is the complex. Here arrangement of ligands we have to write. So here two ligands are there. Consider these two ligands as the identical atoms. If they are adjacent to each other, because NH3 and 4 atoms, of course they are adjacent. Okay, if they are adjacent to each other, then they are said to be what? Cis isomers, adjacent. So if you want to write the same structure here the complex cobalt, here it is NH3, 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 and this one is Cl. So students, if you consider these two, of course they are adjacent to each other. But here, if you consider these two, they are opposite to each other. Understand? If you consider this, of course this become opposite. Consider this become opposite. Understand? So that's why this constitute a transisomers, means the identical ligands are opposite to each other. Understood? So this is one type of isomerism, that is geometrical isomerism in the arrangement of atoms in a three-dimensional space. So the next one is stereoisomers. Next one is in this stereoisomerism, second classification is, that is second one, optical isomerism. Is that optical isomerism? So students, what is optical isomerism? Means the compounds having same molecular formula and structural formula but differ in rotation of plane polarized light. Understand? Differ in rotation of plane polarized light. Okay. What is the difference here? Plane polarized light means so a light which is passed through the quartz glass. So it has two planes, either perpendicular or parallel. Two planes, any one plane polarized light, either perpendicular or parallel. Okay, so that plane polarized light. Listen, I'll say if any constitute light is there, it is like this. It is in all direction. Okay, when it is passed through a quartz glass, this is a quartz glass. Are you getting? So this is a light. It is a divergent light. It diverges in all direction. So when it is passed through this quartz glass, either it forms a perpendicular plane light. This one is perpendicular plane light. Understand? Or parallel. This one is parallel. This is perpendicular. Only one type of plane polarized light will form. This is a divergent light, it is in all directions. But when it is passed through this quartz glass, it forms two planar lights. One is perpendicular, another one is parallel. Understand? So this type of plane polarized light. So it's rotated by this type of compounds. Assume this is the plane polarizer light. Okay, it is like this. If it just turns in clockwise direction or anti-clockwise direction, this one is what? Perpendicular. So if I just turn it 90 degree, it is like this. If I turn like this, it will become like this. Correct? Perpendicular becomes parallel. Here it is parallel. If I just turn this, this becomes like this. Perpendicular. Understand? That is what? Rotation of the plane polarized light. Either clockwise or anti-clockwise. So based on whether it rotates the plane polarized light towards clockwise or anti-clockwise, it is classified as dextro and levo. Understand? So I just have this and I write the examples here. Another one classification, that is dextro rotatory. Okay, dextro D means right. Listen, if the compound rotates plane polarized light towards right. Listen, right means like this. Correct? This is like this. Right means like this. Means clockwise. Called as dextroisomers. So students, only isomers will form. There is no isomerism. Okay? Dextroisomers. So I write the example here. And I take another one, levo also. Levo rotatory. Okay, so here, if the compounds rotates plane polarized light towards right, then it is dextro. Of course, then it is towards left. If the compound rotates plane polarized light towards left. So listen students, this is like this, towards left means in an anti-clockwise direction. Anti-clockwise direction called as levo isomers. So students, remember, all the cis isomers are optical isomers. Are you getting? All the cis isomers, what I explained before, are optical isomers. So I'll take one example here. Like CO NH3 4 times Cl2 plus. So listen students, if I write the compound like this, 2 Cl atoms are here, NH3 atoms are here. Assume if these two results in rotation of plane polarized light towards right, that is represented by capital D or small d or plus. It is represented by D or plus dextro D or plus positive rotation clockwise. So exactly opposite of this, mirror image of this. If we keep this compound opposite to this, then we will get, students, listen. Okay, if we place this compound before the mirror, in front of mirror, so we will observe this Cl is here, this Cl is here, this NH3 is here, NH3, NH3, NH3. So this is exactly a mirror image. then this arm must be rotated. The plane polarized light towards left. Means cis isomers exhibit optical isomerism. Understand? Only there should be a mirror images. So students listen here. So if we get this, understand? Listen here. So here cobalt is this, sorry, 4 times of ammonia is there, Cl2 is there, cobalt is there. Here also same thing. So this is exactly a mirror image. So if you keep this compound in front of mirror, it exactly look like this, opposite. These two are front, these two are here, and these two are here. Correct? So then, if you get this compound like this, and if you keep on this, above on this compound, understand? If you just pick this compound, you keep above this compound, understand? So these two will coincide or superimpose. So this Cl is here, this NH3, this CNH3 is here. Of course, they are superimposed. Means they exactly fit one above the other. But here Cl is there, here NH3 is there. But here NH3, NH3. Here Cl NH3 is there, here NH3, NH3. These four positions are non-superimposable. They cannot place exactly above the same atom. Here NH3 is there, Cl will come, here NH3, NH3, here Cl is there, NH3 is come. So they are not superimposable. So this type of non-superimposable mirror images are called as enantiomers. Non-superimposable mirror images are called as enantiomers. This is the best example. They cannot superimpose. Superimpose means exactly one places above the other. Understand? So here Cl and NH3 are superimposed atoms, and these four are non-superimposable. That's why it is a mirror image. Sorry, mirror image as well as it is an enantiomer. Understand? So next one, students. Here dextroisomer, that is D is there, levoisomer L is there. So mixture of dextron levoisomer, especially equimolar mixture of dextron levoisomers is called as racemic mixture. Okay, that is not in this year. In the next year it is there. I'll explain later. Okay, so this is about isomerism. Okay. So next one is, students, the fundamental concepts in organic reaction mechanisms. Next one is fundamental concepts in organic reaction mechanism. So students, you may already know about the mechanism in biology. Understand how the mechanism takes place. For example, food mechanism. Initially, we ate the food, okay, goes to our stomach. So variable biological process will undergo. Later, it will get out of from our body through excreta. Correct? This is one type of a mechanism. Respiration also. We inhale the oxygenated air, Okay, oxygenated is exchanged in lungs. Okay, and we exhale that deoxygenated air, means carbon dioxide with water vapor. Are you getting my point? So each and everything is a detailed mechanism. In organic chemistry also a mechanism is there. Mechanism means what? A detailed explanation of step by step and cleavage of bond or electron movement is called as reaction mechanism. What is happening here? So listen, in the reaction means reactants will be there, how they react, how the catalyst is involved. Understand? And next, what are the intermediates are formed? After intermediates, what are the products are formed? During the product formation, what is the bond cleavage takes place? Which bond detaches, which bonds will form? So, for example, I'll take, listen, here CH3 OH is there, plus HCl is there. What you will write? CH3Cl plus H2O, correct? This is the reaction, and you know that by seeing that you can easily write. But initially the mechanism will take place. How? So listen, in step one, this CH3OH, write like this, CH3OH, okay, loses OH minus and form CH3 plus OH minus. Next, this HCl also dissociates. HCl is attached here, like right here. CH3 plus is there. HCl is attached here. Don't write. Okay. Then it forms CH4Cl minus. Okay. So your extra is what? H plus ions. Plus extra H plus is there. Then consider CH4Cl. From here you just remove and take like this hydrogen atom. Then you get CH3 Cl plus H plus. So students, here H plus is generated, here OH minus is generated. These two react with each other form H2O. This is how the mechanism takes place. Means step by step. This is a reaction, this is a mechanism. Step 1, step 2, and step 3. Understand? So this is what called as mechanism. Means here listen, I am writing the bond cleavage, formation of the intermediate, everything. Detailed explanation of electron movement, intermediate formation, step by step, rate, each and everything is called as what? Reaction mechanism. Understand? So in that reaction mechanism, what are involved is, one is the main things involved in reaction mechanism is, first one, bond cleavage. First one, bond cleavage. Okay. Second one, intermediates. Formation of intermediates. Okay. Third one, bond cleavage, intermediates, and the third one is what is it? Okay. Electron movement. Bond cleavage, intermediates, and electron movement. So students, in this bond cleavage, two types is there. Heterolytic bond cleavage and homolytic bond cleavage. Understand? And this intermediates are right here. Two types. One is homolytic. Second one is heterolytic. Here also three types is there. One is carbocation, second organoion, third free radical, especially carbon free radical. Okay, so in this electron movement, first one is inductive effect, second one is electromeric, third one is resonance, and the fourth one is hyperconjugation. These are the effects which are going to explain why the displacement of electron from one atom to other atom. So we will discuss one by one. That is bond cleavage, homolytic and heterolytic. Later I will explain carbanion, carbocation and carbon chloride. Listen students. So first one, homolytic cleavage. So I will take homo molecules, homo diatomic or polyatomic molecules. Listen here, I will take H2. So this H2, I will take Cl2, not H2. So Cl2 is here, it is written as Cl. There is a single bond between Cl, it is like this. Understand? So students, here what happens? What is homolytic? This is, listen here. This Cl atom having the atomic number 17, this is also atomic number 17. This is also having same weight, this is also having same weight. This is also having high electronegativity, this is also having high electronegativity. So both are same atoms, means there are physical and chemical properties is also same. Then here the force of attraction or the force of repulsion balances with each other. Means the no one electron can contribute towards any other atom. So here Cl is there assumed. It has highly electronegative than this Cl. Of course, at the same time, this becomes highly electronegative than this, means the force of repulsion and force of attraction is balanced. So then what happens, students? If the bond, always remember the bond cleavage takes place at the middle. Okay? So if the bond cleavage takes place, they form which type of bond? One is Cl dot, Cl dot. These two are free radicals. Dot means why it is called as free radicals? This Cl is dissociated and cleaved with its electron. This one is cleaved with its electron. Are you getting? So this is Cl minus Cl dot, Cl dot. So yellow atoms in the form of the same level. So these two are homo, same. If the atoms formed after the bond cleavage are same, then it is homolytic cleavage. So I will write heterolytic. Okay? Heterolytic. So in heterolytic, you want heteroatoms. So I will take HCl. Of course, it is not an organic compound, then only I take HCl. So among hydrogen and Cl, which one is highly electronegative? Means Cl is highly electronegative. Means it attracts a shaded pair of electron towards itself. So if we observe, then the electron of this hydrogen is at 0. Then what happens, students? As I told you, exactly the bond cleavage takes place at the middle. So listen, if a bond cleavage takes place at middle, then here there is no electron. There is no electron means plus charge. Loss of electron, less electron. How many? Only one. So plus charge. Here Cl, more electron, that is minus charge. Extra electron. Minus represents extra electron. So listen, if you assume H dot and Cl dot, there is no charge here. So if one electron less here, then it becomes plus. If one electron added here, then it becomes minus. That is what I said. So here, after bond cleavage, one will form a cation, another one will form an anion. So both the reagents here are different. Different means hetero. That's why this type of bond cleavage is called as heterolytic bond cleavage. Understand? So what is homolytic bond cleavage? What is heterolytic bond cleavage? They may ask. Homolytic means after the cleavage of the bond, if they form same type of atoms, especially they form free radicals, then they are said to be homolytic cleavage. Then that is said to be homolytic cleavage. If after the cleavage of the bond, if they form cations and anions, here only free radical, here cation and anion, then it is said to be what? Heterolytic cleavage. Understand? So based on this homolytic and heterolytic cleavage, so this type of intermediates will form. One is carbocation, carbon ion, and carbon free radical. So based on this free radical intermediates, we